So we'll get started now. My name is Tim Edwards, and I'm here on behalf of eFabless.com. And as the slide shows, my cohorts at eFabless are Mohammed Qasim, the founder, Mike Wishart, the CEO. I'm helped by Greg Charette and Jeff DeCorpo, who are doing IT, and helping with me on the analog and digital platforms are Risto Bell and Jay Shah. And of course, I want to give a big thank you to Kunal and Anaga Ghosh for their work on VLSI system design and making these webinars possible.
Thanks, Tim.
Okay, there. So the webinar is going to be about, as Kunal gave a very nice succinct review of, to begin with, the building of the Raven chip. And here is, I'm going to give you a little bit of a description of what the agenda of the whole webinar is going to be, and you can follow along. This part will be pretty fast. So part one, I'm going to give you a little bit of an idea on how you design on the eFabless platform. I know last week in the short period of time while I wasn't there that you did do a bit of logging in on the server and poking around, so I'll try to keep that fairly quick. But I will show you all the different parts of eFabless and describe a little bit about who we are and what kind of company we are and what our platform is like. And we'll end that with a simple interactive tutorial in which we will do what we call cloning a project, in which it goes to your workspace and you get to work on it. So that will be followed by part two, in which I'll get into the RISC-V and tell you a little bit about RISC-V for those people who are worried that they don't know much about the ISA, the instruction set architecture. It's not going to be particularly relevant. I'm more interested in getting this chip to a point where you can do C programming and not worry too much about what the instruction sets are. So we're not really going to be looking too much at the interior of the PicoRV, but more of an overview of the structure of it and then see how you build that out from a microprocessor to an SoC, system on chip, and how you build that out into a full chip that you can send into a manufacturer. On part three, I will then, I'm going to go through the whole RISC-V thing, the SoC, several times. One of them is just to give you an introduction to where all the parts are. And then the second part is going to be a little bit more in-depth on understanding what is in the RISC-V and how the SoC is organized and why you need certain peripherals in certain places. And then there will be more details on things like what do you do for the pad frame, what do you do for the voltage domains, and other very hardware-dependent details. That will be followed by part four. Sometimes this works, sometimes it, okay, part four. Design choices. So how do I want to connect all these building blocks together, and what makes a good SoC, what makes a good product? How do I want this to be designed, and what do I want people to do with it, and how is that going to affect the design? For part five, we will get into how you assemble all the parts. So as I said, it's going to be rehashing the whole from the PicoRV 32 core out to the full chip level several times. In this case, we'll just see how everything is organized for simulating and for verifying the chips. So how you do the C code test bench, how you do the Verilog test bench, and then we'll do a little interactive tutorial where I'll have everybody run the test bench suite for the Raven chip. And that'll be followed by a more in-depth interactive tutorial where I will get you to actually write some C code, write some Verilog code, and that you'll be able to actually have written your own quick test bench and run it. Part 7 will be a very, very quick look ahead at what I hope to do on the follow-up webinar, which is to look at how you go about taking this design, which tonight we will look at just simulation in Verilog and do all the parts for layout and schematic verification, all the things that need to make it into a file that you can send out to a foundry and have it fabricated. And finally, has been common for these webinars, there'll be a follow-up challenge, and I will describe to you what that challenge is and what you need to do. And if you can get it done, then you'll be certified, and I'll get into all that in just a little bit. So that's the agenda. So let's get started. Part one is eFabless, all about eFabless. Who are we? Oh, and one more thing I should say is that I'm going to have a tendency to just blow through this thing. And so every now and then, if you think it's time to stop and ask questions, then please interrupt me and say, yes, you should take questions now, because otherwise I'm probably going to go on. I'll try to remember. But
so let's take up a few questions now before moving forward. Anyone has any questions for Tim on the chat box? Yeah, Tim, put the cursor on the top. Just keep the cursor on the top. Yeah, and just move around the cursor. You will see the. Okay, let me do it.
Yeah, I think I'm not sure where the chat box is.
Yeah, this is the chat. So Finman has. So would it be great if you could hit Control L for full screen? Okay, we'll do the full screen thing.
Oh. Do I still have control? So I just do Control L? Control L,
yeah. You can close this, yes.
Okay, all right. That's good.
As a query, can we cover all of that today?
Yeah, everything that I said, except for the part where I said I'm going to do all the things that have to do with the back-end processing, layout, and so forth for follow-on webinar, because there's too much to cover. And even in a 4-hour webinar, there's too much to cover with just the simulation and Verilog, all that, and just describing the system. But yeah, everything in there is going to get covered tonight.
All right, we can move on. And anyone, if you have any questions, Tim is anyways going to stop at certain points where he's going to open up the forum for queries. And if you have anything, you can just put it in the chat box. Yeah, Tim, over to you.
Okay. Sorry?
Yeah, Tim, we are done. You can start now. You can close the chat box and we can start.
I don't have a chat box open.
Oh, okay, just a minute. Yeah, okay.
Okay, do I have control of this? Okay.
Yes, you have control.
All right. So, the first part is designing on eFabless.com. So, who are we? eFabless is a community-based web platform for designing, selling, sharing, creating, validating, documenting, and promoting intellectual property for electronic circuits. I will use this term IP a lot for intellectual property. I'm not particularly, I don't particularly like the use of that term, but it's pretty common and we use it all the time at eFabless. So whenever I refer to IP, I'm referring to generally a circuit design, something that is somebody's intellectual property. And all the things I just said, that is just what I pulled off the top of my head when I was writing this. But our one major focus is the design, simulation, and characterization of VLSI schematics and layout and digital synthesis using open source EDA tools. We're not wedded to open source. We have certain tools that are closed source, proprietary tools, but we do like open source tools. The reason is because if you want to go with a closed source tool, you have to pay for it. If it's something like Cadence or Mentor Graphics, they want to have payment for every seat. If you want a platform that can be opened up to the world and you want everybody to come in and design, then that gets very expensive if you have to pay for every time somebody uses one of your tools. So we try to stick with the open source free tools, and as Kunal mentioned in the introduction, I'm one of these people who likes to collect open source tools and write the ones that I feel that are needed and don't exist. So I've been writing and developing open source tools for quite a long time, and many of those are on the platform as well as many others, because there are certainly lots of open source EDA tools out there, and they are quite as capable, I think, as most commercial tools.